On this problem solving a system of 3 equations in 3 variables, we're going to solve for x, y, and z. So the answer at the end is going to be, instead of an order pair, an order triple. And we're going to find even the value for z, not only for x and y. So you're going to start using one of the first 2 equations. One of the first 2 out of these 3 equations, whichever 2 you want. You can choose the first one with the second one with the third one, or first one with the last one. It doesn't matter. I'm gonna choose to use the first 2 just because, not for any particular reason. So you write them one underneath the other, and then you have to do like addition method, because you're gonna use addition method with this. You have to think, which 2 variables can I cancel, which 2 like terms can I cancel, the x's, the y's, or the z's. And the way they are, none of them can be canceled. On purpose, I'm going to choose to cancel the y's, taking advantage the fact that, and I left not enough space here, that the y terms already have opposite signs, as well as the z's, but I don't know why I'm just gonna go with deciding to cancel the y's. So since I have a positive 3y on the second equation, I would like to have a negative 3y here. And since there is already a negative 1 here, let's just do 3 times negative 1, obtain a negative 3y to cancel with positive 3. So 3 times 6x is 18x, 3 times negative y, negative 3y, and 3 times positive 3z, 9z. 3 times negative 17 is going to be negative, 3 times 7 is 21, 3 times 1 is 3 plus 2, 51, negative 51. You copy the second equation underneath this one, and then you're going to add both equations, adding like terms, because that's why we're using addition method with this. So we're going to have 18x plus 1x, 19x, negative 3y plus 3y cancels, 9y minus 1z, it's going to be plus 8z. Negative 51 plus 8 is going to be negative 43. Let me just double check. 51 minus 8, yeah, negative 43. So let's call this to be equation 1. And why am I calling this equation 1? Because the next step is going to be using 2 equations from the originals again to form another equation that is going to be written in terms of x and z only, that is going to have no y. So you must use the third equation that you have not used at all in combination with one of the other 2. So just because I'm going to choose to use the second one with the third one, obviously, because that one I have no choice by using it because I have not used that one. So the same equation the same variable, that I canceled in the other 2, I need to cancel here. So I don't have a choice of, do I cancel the x's or the z's or the y's? You must cancel the y, as well as you did in the previous set of equations. Since you see the y's have 3y and positive 3y, let's use multiplication times a negative 1. I'm choosing to multiply the first equation times a negative 1. Now, why I'm not multiplying the second one times a negative 1? Just because there's not a specific reason. So negative 1 times x, negative x, negative 1 times 3y, negative 3y, negative 1 times negative z, plus z, negative 1 times 8, negative 8. So you start adding. Negative 1x plus 3x, 2x, negative 3y plus 3y, cancel, 1z minus 4z, negative 3z, negative 8 plus 15, positive 7. So that one is equation 2. Let's call it equation 2. And so now you're going to set one equation underneath the other one. Equation 1 And then underneath equation 1, let's write equation 2. And then you're going to start adding. Oh, but you need to cancel x's or z's. None of them can be canceled the way they are, but we can take advantage of the fact that the z's have on their coefficients opposite signs. We just need to have the same number, the same coefficient on both. So let's multiply times 8 here, and let's multiply this one times 3 here. So 3 times 19 is going to be 57x. 3 times 8 is 24z. 3 times negative 43. Negative 129. 8 times 2 is 16x. 8 times negative 3, negative 24z. 8 times 7, 56. And now you add the two equations. So 57 plus 16, it's going to be 73 x. 73x. This to cancel. Equal 129 minus 56, 73. But it's a negative 73 because the largest number is negative. Divide by 73. And you obtain x equals negative 1. So from the order triple, you have the x. I need to find the y, I need to find the z now. So to find the y or the z, what you're going to do is you're going to get one of the two small equations that you made, equation 1 or equation 2, whichever you want. I'm going to choose equation 2. And we're going to substitute in there the value for x, and we're going to solve for z. Just double check that I did copy it right. 2x minus 3z equals f. So 2 times, so this negative 1 is going to go here. 2 times negative 1, negative 2, minus 3z equals 7. Add 2 to both sides. So that's going to be negative 3z equals 9. Divide both sides by negative 3. So z is equals to negative 3. So now that you have the x and the z, now you need to find the y. And how are you going to find the y? Well, now you're going, the last variable is going to be found by going back to one of the three original equations, substituting the ones that you know, x and z, and solving for the one that you're missing, the y. So I'm going to use the second one from the original. X plus 3y minus z equals 8. So x, it's a negative 1 plus 3 times y minus a negative 3 equals 8. So negative 1 plus 3y, negative times a negative, it's a positive 3. We're going to combine this two. So negative 1 plus 3 is going to be a positive 2, sorry. So 3y plus 2 equals 8. Subtract 2. 3y is equals to 6. And then you divide by 3. So y is equals to 2. So what's the solution? It's going to look like the following. Negative 1, that's your x. The y is a 2. And the z was a negative 3. Now that you know how to solve a system of linear equations looking very similar to this one, 3 equations with 3 variables, you know that you can use matrices, that you can verify with the calculator your answers, or you can use the method of solving these systems by using matrices, or using this method. It's also another alternative for when you have 3 equations with 3 variables. The addition method, which is this one, or the solving the system of linear equations by using matrices that you know, making the diagonal of ones and so forth. So I just wanted you to see the connection between these 2 methods. They give you the same answers, but you do different ways to get these answers. Okay, but this system is called addition. This one, let's see what's next. Okay, this one, it's I guess solving the same way. So let's see. We're gonna get, let's see, we can choose to do, I'm gonna use this time the second and the first equation. X plus y minus z equals 6. 2x plus 2y plus z equals 0. Let me tell you why I chose the second and the third equation, because I saw that these two have the terms that have the z's ready to be cancelled. Negative 1z plus 1z cancel. So I said, let me do those two, and that way I don't need to deal with, okay, what do I cancel and what do I multiply times? It's already there. 1x plus 2x, 3x. 1y plus 2y, 3y equals 6 plus 0, 6. So this is going to be equation 1. Then I have to use the one that I have not used, which is the first equation with one of the other two. And if you look at this one, okay, the thing about this problem is that yes, you technically for the next step would have to use the equation that you have not used, which is the first one, in combination with one of the other two. But if you are very observative, I cancel the z's on this two because I said, they're ready to be canceled. And also, that third equation that I have not, well, the first equation that I have not used does not have a z. So that means from here, I can go straight to step 2, being writing down the equation 1 that I got, and then underneath this one, writing this one right here, 4x plus y equals 2. Because anyway, they're written in terms of the same variables already. Now, I would like to cancel one of the variables, whichever you want. I think the easiest thing you can do is, since you have a 1 in front of this y and there's a 3 over here, why not multiplying here times a negative 3? So the first equation, 3x plus 3y equals 6. And the second equation is going to be negative 12x, negative 3y equals negative 6. So 3x minus 12x is going to be negative 9x. These two are going to cancel, equals 0. Divide by negative 9. So x is equals to 0. And so now that you have x equals 0, you can use this into one of either equation 1, or it can be the original first equation. You can plug it in to find y. So that's what I'm gonna do. I'm gonna use the first equation, 4x plus y equals 2. So 4 times, we're gonna put 0, plus y equals 2. So 4 times 0 is 0, plus y equals 2, y is equals to 2, because 0 plus y is just that, it's just y. And then if I want to find, I have x and y, now I want to find z, use one of the original equations. So use the second one, let's say, x plus y minus z equals 6. Okay, what's that? Yes. So x, it's 0, y, it's 2, minus z equals 6. So 0 plus 2 is 2, minus 6, minus z equals 6. Subtract 2. So you have negative z equals 4. Divide by negative 1 to get rid of the negative at the front of the z. Z is equals to 4. So the solution, it's going to be 0, 2, and 4. Okay. 5.4 systems of nonlinear equations in two variables. So this is the last section. Systems of nonlinear equations in two variables. So we're not going to see equations that have three variables now. We're not going to see three equations at a time. But these equations, the characteristics is that they're not, when you graph them, they're not lines. That's why they're called nonlinear. So you will see that some of them have higher exponents than 1. Equations where the highest exponent is a 1, it's called linear. But once you start seeing equations higher than 1, then they're nonlinear. They're other kind of graphs or functions. So we're going to see again the two methods that we went over already, substitution method and addition method. The idea is the same in substitution. You need to have one equation solved for a particular variable, and then you have to substitute that into another equation. Find the easiest thing to do all the time. There's always an easier route, there's always a more complicated way of getting the same answer. So this time I'm going to choose the second equation. I'm going to solve for x, let's say. I could have solved for y, but I'm going to choose to solve for x. And so I'm going to do x equals y plus 1, or 1 plus y, however you want to write it down. And so into the x, so let's say this is step 1. Oops. Into the x of the first equation, you're going to substitute now the value that x has here, which is y plus 1. So I'm going to copy the equation that we have not used, and x is going to become y plus 1. But see, that's x now. X is equals to y plus 1, and x was squared. So you're also going to square that. You're also going to square the expression y plus 1, which is representing the x now. So you're going to FOIL this. Y plus 1 times y plus 1 plus y squared equals 181. So y times y is y squared, y times 1 is y, 1 times y is y, and 1 times 1 is 1. So all I was doing is foiling this one times this one, this one times this one, this one times this one, this one times this one. So combine like terms. You have y squared, and the two terms that have y. So 1y squared plus another y squared, 2y squared, plus 2y, plus 1, equals 181. So move all your terms to one single side. So since most of them are already on the left side, let's take the 181 to that side. So 2y squared plus 2y plus, no, minus is going to be this 10, minus 180 equals 0. So factor from the three terms. What's in common to them? All of them have in common the fact that all the coefficients can be divided by 2. 2 times y squared is 2y squared. 2 times y is 2y. And 2 times negative 90 it's negative 180. Then this 2, you're just going to keep bringing it down. And you can factor again this entire expression in the parentheses as a trinomial. So y times y is y squared. Two numbers that multiply together gives us 90, but subtracted gives us 1. So that would be 9 times 10. 9 times 10 is, or 10 times 9, it's 90, and subtracted they're 1. So the biggest number goes first, and then 9, this, whatever sign you have in the middle term, you use it on the first one. You have a difference at the end, so this second sign has to be different from the other one. Then, these are your three factors that are multiplying times each other. You're going to equal them to 0. And on this one, 2 equals 0, it's a false statement. That's not true. 2 is not equal to 0, and since there's not a variable to solve for in there, we're just going to disregard that expression. But here, we're going to solve for y on these two other factors. Minus 10, y is equals to negative 10, plus 9, y is equals to 9. So, what about these numbers? Well, these problems in this section are going to have more than one answer sometimes, more than one or their pair that is the solution. They're going to be intersecting at more than one point. So here, you have two y values. So there must be two x's corresponding to each of this. So what you're going to do is you're going to substitute into one of the original equations these two values one at a time to solve for x. So I'm going to use the second equation, I'm going to use the second one. X minus y equals 1 in both. And I'm going to substitute x minus negative 10 equals 1, x minus 9 equals 1. And we're just going to solve for x, so minus 10, x equals negative 9. See, negative times a negative, I made it a positive here. So this is the x that corresponds to this y. So I'm going to write here the order pair is negative 9, comma, negative 10. And then over here, plus 9, x equals 10. So here it's 10, comma, 9. So these are the two solutions. The computer is going to tell you to write them separated by a comma. So in between them, put a comma. Okay, you type one, comma, the other one. You don't have to leave spaces in between them, okay? Just type one point, comma, and then the other point. This next one. So this is by the substitution method. So now it's substitution. The other one was addition. No, I'm sorry, the other one was substitution too. So this is another example of substitution. Here, ask yourself what would be the easiest thing to do. Solving the first or the second equation for a particular variable, and for which one? The first one I would not do, because look, if you do, let me solve for x here, or for y, whatever you want to do, let's say for y. You divide by x, and you're going to end up with a fraction. Dealing with a fraction is not the easiest thing you can do. So, and even if you solve for x, it's going to be the same story. So I wouldn't use the first one. I would use the second one. And the easiest thing you can do is solve for y. Don't solve for x, solve for y. because the x has a coefficient at the front, which is going to make you do more work. You might end up with a fraction, so I don't think that's the best thing you can do. Trying to leave the y is the easiest thing. So negative y equals negative 3x minus x. Divide by negative 1. So y is equals to positive 3x plus 6. So okay, this, we're going to substitute it where? Well, actually the value for y. The value for y, we're going to substitute it into the y of the first equation. So you get the first equation. xy equals 24. And we're going to substitute into the y the expression that y is equals to from the previous step. So x times 3x, 3x squared, x times 6, 6x. You cannot combine these two, they're not like terms. One has an x squared, one has just an x to the first. So I think the only thing we can do is subtract the 24. So I think we can do greatest common factor again. All these numbers are divisible by 3. 3 times x squared is 3x squared. 3 times 2x is 6x. 3 times negative 8, negative 24. So bring down the 3, but then you're going to factor this more as a trinomial. So x times x, x squared. Numbers that multiply together give you 8 and subtracted give you 4. 4 times 2, plus and minus. You already know that this 3 is going to be ignored because 3 equals 0. It's not something you can solve for x because there's not even an x to solve for. But you're going to solve the other two expressions for, or equations for x. Sorry. So x is equals to 2. So x equals negative 4, x equals 2. What are you going to do? The same thing you did in the other problem. You're going to substitute these values into one of the originals. Where, let's choose the first one. xy equals 24, xy equals 24. So x is negative 4. I'm going to put it in parentheses. That is going to be multiplying times the y. The other one is going to be 2 times y equals 24. So since negative 4 it's multiplying times y, the opposite is dividing. Do not add 4 thinking, it's it's a negative, so let me add 4. No, the opposite of the multiplication is division. So you're going to divide by negative 4 both sides, and you get a negative 6 here. Here you're going to divide by 2 both sides, and you're going to get y equals to 12. So what are the two, or their pairs are going to be negative 4, comma, negative 6, comma, and the other one is going to be 2, comma, 12. Those are the two solutions. Okay. So this problem was a substitution problem with nonlinears as well as this one. Let's look at the next one. Solve the system by the addition method. So for addition, we can only add like terms, right? And that's what you have here. X squared with x squared, y squared with y squared. The x's need to have the same exponent, the y's as well. I cannot cancel the x access x squared terms or the y squared terms because they don't have the same coefficient with opposite signs. But I do see that the y squared terms have opposite signs already. Let's just simply use their coefficients to multiply the other equations by them. So these ones are going to be 2 times 4, it's 8x squared, 2 times negative 3, negative 6y squared, 2 times negative 8, negative 16. 3 times 5, 15x squared, 3 times 2, 6y squared, 3 times 13, 39. So now you can add 8x squared plus 15x squared, it's going to be 23x squared. These two cancel, negative 6y squared plus 6y squared equals negative 16 plus 39, that's going to be positive 23. And then divide by 23, both sides. So x squared equals 1. Since we want to know the value for x, not for x squared, we have to do the square root on both sides to cancel the exponent 2 and the square root. That way I'm going to bring down x. The thing is that every time you do the square root of a number when solving an equation, you have to put a plus or minus. So we're going to do plus or minus 1. So there's not only one x value that you got here, you got x equals positive 1, x equals negative 1. So in reality there are two. X equals 1 and x equals negative 1. Or whichever you want to write first, doesn't matter. So I need to find the corresponding y's for these two x's. So use one of the originals, whichever you want. Let's say we're going to use the second one. And I'm going to plug in into the x, 5x squared plus 2y squared equals 13. Into this one we're going to use the same thing, 5x squared plus 2y squared equals 13. So 5 times 1 squared plus 2y squared equals 13. So using the order of operations, first you're going to do the exponents. 1 squared means 1 times 1. Dale. Sorry. Sorry about that. My doorbell rang and my dogs started barking like crazy. Okay, so 1 to the second power, 1. So you just rewrite all this. 5 times 1 would be the next step, 5. Then subtract 5 from both sides. That's going to be 2y squared equals 8. Oops. Then divide by 2. So that's going to be y squared equals 4. Then we're going to do the square root on both sides. So you're going to end up again with two values for the y, plus or minus 2, because the square root of 4 is 2, but because of the square root, you're going to have to do plus or minus. So let's backtrack what we did. We substituted a single x value into the x, and we obtained two y values. That means that you have, just with this substitution, this point, 1, 2, and also this point, 1, negative 2. But keep in mind that that's not the only substitution that I have to do. That was just substituting x equals 1. What about x equals negative 1? Well, you're going to do the same thing. 5 times negative 1 squared plus 2y squared equals 13. So negative 1 times a negative 1, again, is going to be a positive 1. So you see, you're going to do the same process. You're probably going to end up with the same answers on the y, but the x coordinate here is different. So the points are going to be different for this substitution. 5 times 1 is 5, subtract 5. So 2y squared equals 8, divide by 2. So y squared is equals to 4. Again, you do the square root. So y is equals to plus or minus 2. So the points for this one are going to be negative 1, comma 2, comma, negative 1, comma, negative 2. So all together, because you should type them like that on the computer, 1, comma 2, comma 1, comma negative 2, comma negative 1, comma 2, comma negative 1, comma negative 2. So there are 4 solutions in total for this problem. So be very careful, because if you forget the plus or minus, you're going to think that there's only 2 points in total as the solutions. One for the first substitution of x equals 1, one for the second substitution of x equals negative 1, and that is not true. And the last problem, solve the nonlinear systems of equations for real solutions. It doesn't tell us what method to use, substitution or addition. So you're going to have to think carefully, what method can I use here? I do not think that you can use addition. For addition, you need to have like terms. I have x squared and x squared. I have y squared, but then y plus 1 squared. These don't look the same. So probably the best thing you can do is substitution. Okay. So I'm going to choose the second equation, and I'm going to solve it for the easiest thing that I can think, which is x squared. Let me think. I'm double checking if that is the easiest thing to do, or no. The first one is the easiest one to solve for a variable. The first one. X squared plus y squared equals 1. Let's solve for x squared. Okay, so we're gonna send this one here. You'll see why I said this was the easiest one right now. X squared equals negative y squared plus 1. So this is the value for x squared, right? And there is an x squared here. This one. So you're going to substitute into that x squared of the other equation the value that you got here for x squared. So here, I'm going to copy x squared plus y plus 1 squared equals 4. X squared, I'm going to put it in parentheses, and inside I'm going to put negative y plus 1, but x was squared, so this one's going to be squared too, plus y plus 1 squared equals to 4. So we're going to FOIL. Negative y plus 1 times negative y plus 1 plus y plus 1 times y plus 1 equals to 4. So negative y times a negative y, positive y squared. That would be this too. Negative y times 1, negative y. Y times a negative 1, negative y. And 1 times 1, it's 1. So that's going to be the multiplication of all this one. Now let's move on to doing this one. Y times y, it's going to be y squared. Y times 1, it's going to be y. 1 times y, it's just y. And then 1 times 1, just 1. So let's combine all the like terms that we can. We can combine y squared plus y squared, that's going to be 2y squared. Then we can do negative y with negative y, positive y with positive y. See, all of this is we're going to end up canceling them. Negative y cancels with one y. This negative y cancels with one y. Wait, put it 2 to the side. So they all cancel. And then we bring down the 1 plus 1. It's going to be 2 equals 4. Subtract 2. 2y squared equals 2. Divide by 2. So y squared is equals to 1. But then we're going to do the square root on both sides. So y is equals to plus or minus 1. So you see how we ended up with two y values again. Y equals 1, y equals negative 1. So that means I'm going to have to substitute those two y values back into one of the original equations to find the corresponding x's. Sorry about my cell phone ringing. Okay, so we're going to substitute the two y values back into one of the originals. So I think the easiest one would be the first one. So we're going to do into this one. We're going to do x squared plus y squared equals to 1. I think it was 1. Yeah. And this other one, x squared plus y squared equals to 1. So x squared plus 1 squared so x squared, 1 squared is just going to be 1. 1 times 1 is 1. Then you subtract 1 from both sides. X squared equals 0. Then you do the square root on both sides. So x is equals to 0. So here you don't have to do plus or minus 0 because 0 is a neutral number, so there's no need for you to do that. This one, if you substitute a negative 1 and then you square it, it's going to turn anyway into a positive 1. So the only difference is that the y coordinate is different, right? That's the difference. But negative 1 times negative 1 is just going to be a 1. Negative 1 or minus 1. X squared equals 0 again. You do the square root. They cancel, so x is equals to 0. So it's a matter of just writing the right order pairs. This one was 1, 0, comma, the other one is going to be negative 1, 0. And that's what it is. And that's the end of section 5.4. Okay. So you just need to identify that there's two methods: addition and subtraction. Addition and substitution. I'm sorry. And you need to realize that there are some systems that are 2 equations, 2 variables in 5.1. 5.2 it's about 3 equations, 3 variables, and there you only do addition. And that one is the kind of problem that you can also solve using matrices, now that you know about that in chapter 6. And 5.4 it's solving systems of 2 nonlinear equations. And you see that there are multiple solutions in this kind of problems. And that's the end of it.